Welcome. In this example, I will be modeling a simple tail ditch. First step will be to create a horizontal alignment. The second step will then be to create a vertical alignment. Thirdly, then we'll create the corridor model by applying one of the standard NCDOT ditch templates. And finally, we'll make some adjustments to the ditch corridor by adjusting the horizontal and vertical alignments. And then later in a separate video, I'll demonstrate making adjustments to the ditch corridor using template drops and parametric constraints. All right, first step, I'm going to make sure that I'm in the right workflow. Go to Open Roads Modeling. Then I'm going to set the right feature definition. My feature definition toolbar, go to Linear, Hydraulic Modeling, and my ditch baseline, and make sure to set that as active. We want to turn on that toggle to use the active feature definition. Now that I've got that done, I can go to my Geometry tab, go to Complex Geometry, Complex by PI, and I'll go ahead and lay out a series of PIs using this reference. I have a file referenced up to guide as a guideline, so I'll go ahead and use that. My tool settings dialog, I'm going to go ahead and provide a name for this using the DOT standard convention here. This is off the L line, the station at the beginning, the roadway baseline station at the beginning, and it's on the left side. I'm going to set my value of radius to 0 for now, and make sure that my ahead and back transitions are set to none. I'll go ahead and start here at the beginning. I'm going to snap to these points. And then when I'm finished, I'll right click to complete the process. And now I can turn off that reference file. Now there's my baseline. At this point, if I want to add a horizontal curve here, I can go to my table editor, select it, and then just add a radius at any of these points. It will not take effect until I hit apply. I can also, by selecting the alignment, use the manipulators to change radii or to change the PI points. At this point, I have a horizontal alignment, but I do not have yet a vertical alignment. If I look at the attribute feedback, you can see that it says no active profile. So I need to create a profile. But first, I want to select a contour from the existing terrain. From the flyout menu, set it as the active terrain model. Now I'm ready to create a profile model. I'm going to select the baseline, and then from the flyout menu, select Open Profile Model, and then select an open window. And now that is showing me the existing terrain along the horizontal alignment. Go to View Attributes and change my exaggeration to 5. Now I'm ready to go ahead and create a profile. We go to the vertical area, vertical tool group, and under Complex Geometry, Profile Complex by PI. The tool settings dialog, I want to make sure that my curve length is set to 0. And we'll put a name in here. Now I can start creating my profile by snapping to PI points. In the beginning, I'm going to snap to the beginning of the profile, and you can see I'm getting the snap indicator here. At this point, I'm going to use Civil AccuDraw and put this in my station elevation mode. And that allows me to put in specific stations if I wish. So now it's locked on that station. I can give it an elevation, enter to lock it, data point to accept it. Now I can go to my next point. Now I'm going to change this to slope mode, and I can put in a specific slope as well as a station. So I'll go ahead and put this in at station 200, lock that in, and then specify a slope of -5%. Press enter to lock that, and then data point to accept it. I'll turn off Civil AccuDraw and just simply snap to the end. At this point, if I want, I can hit the right arrow key and specify a particular slope if I want at this point. I'm just going to snap to the end and then right click to exit the process. And as before, I have manipulators that I can now use if I want to make edits to either station or elevation. I can do this graphically, or I can use the text manipulators. And don't forget this last step. Select the profile, and from the File menu, choose Set as Active Profile. That will then associate this profile with the horizontal alignment. When I do that, you see that it now appears in the 3D model because I now have horizontal and vertical information, so now a 3D element. Now that I have both a horizontal alignment and profile, an active profile, I can now create a corridor model. Go to the Corridors tab. Before I can create a corridor model, I need to load a template library. This is done by going up to the Create tool group, to the Template tool. I'll go to File, Open. Now, this is found in the NCDOT Connect Workspace folder. Go to Configuration, Org Civil, Disciplines, NCDOT Hydraulics, Standards, and finally, Template Library folder. And then that's the file you want. And then you can close the dialog. Now that I have my template library loaded up, I can go ahead and start the process of creating my corridor. So I'll go to the Create tool group under New Corridor, and then follow the prompts. It says Locate Corridor Baseline, so I can go ahead and locate that. Next prompt, Locate Profile or Reset for Active Profile. It does have an active profile, so I'm just going to reset to accept that. It automatically populates the corridor name based on the name of the alignment. I'll go ahead and accept that. And now I get a temporary shape that comes up for the corridor. Sometimes if you just move your mouse, you'll go to the next step, sometimes not. You can go ahead and select that. And then from that menu, go to Corridor Creation Tools, Create Template Drop. And that'll bring up that next prompt if it doesn't come up automatically. So here, you can either go to this button to bring up the Pick Template dialog, or if you're staying in the heads up, you can just press Alt down arrow key, and that will bring up the Pick Template dialog. So I'm going to go to my head and tail ditches category and just select the simple riprap ditch class B, and then say OK. And then data point to confirm that selection. And then for the start and stop station, I don't have to apply that template to the entire corridor, but I'm going to go ahead and do that. I'm just going to press the Alt key to lock it to the beginning, data point to accept that, press the Alt key again to lock it to the end, data point to accept. And then the last step is to select a drop interval. I'm going to go ahead and use 5 and data point to accept that. When I do that, the corridor is created. And you can see that in both plan view and 3D view. At this point in the plan view, I'm going to turn off display of the 3D model. And in the 3D model view, I'm going to turn off the levels associated with the contours. Now that I have a corridor, I want to create a dynamic section view. I can go up to the Review tool group area and go to Dynamic Sections, open cross-section view, or I can select the corridor itself from the flyout menu, select that, open an available window, and put it there. And now you see I have the ditch and any other 3D data in the 3D model shown in the dynamic cross-section view. Once I'm here, there's a number of ways to navigate through this. You can put in specific stations through this drop-down. You can use the arrow keys to go back and forth. Also, you have some options. If you right press in that window, locate station via data point, you can then either identify a location in a profile view or a plan view. When I click in the plan view, you can see I have a slider now, and I can snap to a particular location, or I can key in a specific station and it will go there. And then finally, another option, once you have the dynamic view established, you can go into the plan view, and once you select the corridor model, you get this slider, which you can then slide graphically to quickly view the cross-section in any particular location. Also, go to the 3D model view. Very helpful tool is the view rotation tool. When you select this, you'll get this X. Make sure that you grab this and put it on something that you can snap to. You get that yellow cross there and snap. That way you can it'll then rotate and move around that point. If you leave that X out in space somewhere, it can be very difficult to use this tool.